Yippee! We've made it to the end of Module 8. This is the last video in Module 8, Interpolation and Spatial Statistics. Last time I talked about clusters, about where your data are. Are they clustered or are they dispersed? Are high values or low values clustered or are they dispersed? There's a variety of statistics you can look at to give you an idea about what's going on with your data. There's some other tools I need to show you. One is grouping analysis. That allows you to take an input data set with a bunch of attributes and to break it into groups. You can tell it how many groups you want to break it into, and you can tell it which attributes you want to base the groupings upon. It's going to do its best at grouping things so that attributes in groups are more similar than attributes in other groups. Now, this isn't a perfect algorithm, so it's going to do its best. Similarity search allows you to give the algorithm a feature that you want to match. It looks in a target set of similar features, and based upon the attributes that you want to match, it's going to tell you which features in your target set are most similar to the feature you want to match, and it's going to give those an index that got a higher number. So you'll come with an output data set that has an additional attribute which is a similarity index. You can imagine this maybe applying to, let's say this is a city, and your city may have population, it may have climate, it may have all kinds of information attributes associated with it, and you might have all the cities in the United States in another data set, and you might want to know which cities in the United States are most like my city. You could do a similarity search and it would come up with similarity indices for all the cities in the United States. Linear directional mean does exactly what you think it does. When you have a bunch of linear data, if there's a trend in the direction of those lines, it will average those out and it will give you a direction of the mean direction for those lines. Regression. So far we've talked about looking at the where of your data, looking at the what of your data. Are there clusters? Are there not clusters? Where are there clusters? Things like that. Sometimes you'd like to ask the question, why are there clusters? If your data aren't random, why aren't they random? So you run all these statistical tests and you've determined that things aren't random for one reason or another. You might start asking why that is. And regression is going to allow you to take a look at maybe why that is based upon the attribute values in your data. And so you can do regression on your data by asking it to fit a surface to the attribute values that you expect may be related to each other. So you can have what's known as a dependent variable and independent variables, and you can ask it to fit a regression between those two to give you a relationship between the independent variables and the dependent variable. Exploratory regression allows you to have ArcMap, an algorithm, look at your attributes. You can say, look at all these attributes and tell me if there are relationships between these attributes and the attribute that I'm interested in. So let's say you have something like obesity data across the United States, and your obesity data also has a bunch of attributes about things like education level, income, family status, things like that. You could ask the algorithm to look at the relationships between those other variables and see whether there are correlations between those attributes and the obesity attribute that you're looking for, asking why it is that obesity is not random, that it clusters in certain areas of the United States. Those are the kind of things you can do with exploratory regression. Geographically weighted regression says, let's look at pieces of the study area and just calculate the regressions for the data that's within a certain subset of my data sets. So you can get regressions that will vary across your map depending upon what the relationship is locally. And so you don't need to do it for all of your data. You can break your data into pieces and see if there are different relationships between attributes in different parts of your study area. I've gone through a lot of statistics in this last few videos, and I want you to feel a little bit less frustrated maybe about all the data that I've covered, all the information I've gone over. You don't really need to remember the details of all these statistics and what they do. You do need to remember that there are tools out there that you can use to ask questions about your data. You can ask questions about what your data are. What are the values and where are they? So you can ask what questions, you can ask where questions, and with things like regression, you can ask why questions. So when you want to start looking at your data and seeing whether there are patterns and maybe why there might be patterns in your data, you'll need to look back at these statistics tools and look a little deeper into them. One of the ways you might do that is you might think about this certificate program in GIS that we have at the university. And that certificate program involves 2 core courses, the one you're taking right now, Geography 385, and intermediate level, Geography 475, and then you take 3 electives from the remaining courses down here. And one of the courses is Spatial Analysis and Modeling. So if this material that I've covered in Module 8 is interesting to you, you might think about signing up for Spatial Analysis and Modeling. And if you pair that with a couple of these, then you're only 2 other courses away from having a GIS certificate from the university. Okay, one more module and we're done with the modules for this course. And the next module is going to cover GPS and remote sensing. So tune in next time and we'll talk about GPS. Thanks for watching.